Hi, everyone. Welcome to our presentation on nuclear microreactors at WPI. I'm Patrick Haggerty.
I'm Derek Baker.
I'm Leonardo Coelho.
I'm Maxwell Dargy.
And I'm Devin Williams.
It is well understood that carbon emissions cause many negative impacts on Earth's climate. WPI relies on energy sources that produce a lot of carbon emissions, and it is actively planning to implement a natural gas cogeneration plant onto campus that will continue to do so. Additionally, WPI has no opportunities for nuclear research on campus, as they decommissioned their research reactor in 2011. By implementing a nuclear microreactor, WPI could solve both of these issues at once. Nuclear energy has one of the lowest life cycle carbon emissions of all energy sources, and microreactors are no different. Microreactors, which are a subset of small modular reactors, are nuclear reactors that are designed to be economically viable at a very small scale, and they can be small enough to fit in a truck bed. WPI is in contact with the company Westinghouse, which is developing a microreactor design called Evinci, which should be commercially available by 2026. So we researched their design. The Evinci model can produce enough energy to power and heat campus almost completely by itself and can simultaneously be used for nuclear research.
The goal of our project was to study the feasibility for WPI to implement a microreactor on campus. To do this, we researched WPI's energy infrastructure, carbon emissions, and energy usage, and we investigated the Evinci microreactor's energy production, carbon emissions, and research capabilities. In doing so, we interviewed experts in various backgrounds: an employee of a microreactor manufacturing company, Westinghouse, a leading member of MIT's nuclear research program, a nuclear researcher and professor at WPI, and an engineer working at WPI's power plant. To guide our research, we conducted a survey of the WPI population to gather opinions.
We found that microreactor technology can benefit WPI by providing research opportunities and producing clean energy. The Evinci reactor is capable of the same sorts of research applications of traditional research reactors, with applications such as irradiation of samples, medical isotope production, and much more. It allows for experiments both in core and on the periphery of the reactor, and can do so with a high neutron flux, allowing for neutron-intensive applications. Based on our analysis of the electricity and heating needs on campus, the Evinci reactor can produce more electrical and thermal energy than WPI uses on average. However, the output of the reactor may not meet the instantaneous needs during peak usage hours, so a system to provide backup energy would be needed. Still, with the proper implementation, the Evinci microreactor could almost completely offset WPI's carbon emissions from using non-clean energy due to its low carbon footprint.
From our survey of the WPI community, we found that if WPI were to move forward with having a nuclear microreactor, it would not encounter much resistance from the WPI community. Of the 210 people who responded, around 72% were supportive of using a microreactor for power generation and research, and around 7% were opposed, with the rest being undecided. Additionally, the main concern that participants brought up by far was the safety of the technology. We determined that the Evinci microreactor should be completely safe to have on campus with very low risk. The reactor and its fuel are engineered to have inherent passive safety features that prevent a nuclear meltdown. The reactor also has multiple ways to manually shut down operation in the rare event of an emergency. Unlike current research reactors, such as the reactor at MIT, the Evinci microreactor does not need to be actively operated, and instead only needs to be passively monitored, which can be done on a laptop. However, if microreactor technology becomes more popular, there may be safety issues regarding waste storage and proliferation. These issues must be addressed before microreactors are adopted widely, but they do not affect safety on campus.
To accomplish WPI's goal of reducing the campus impact on the environment, we recommend that WPI implements a microreactor on campus instead of other cogeneration proposals. Our findings indicate numerous benefits for WPI and the environment as a whole. WPI would become a leader in nuclear research as well as in utilizing clean energy. As such, we recommend that WPI reconsiders its plan for a natural gas cogeneration plant. We recommend creating a board of faculty, students, administrators, renewable energy professionals, and representatives from Westinghouse and National Grid to act as a leadership group to push and further develop the project. This board will focus on the following tasks: conducting a comprehensive survey of the WPI community and surrounding Worcester community, identifying a location which the reactor could reside, and developing an installation and integration plan for the reactor. Thank you for taking the time to listen to our presentation. Please feel free to reach out over email, and we'd be happy to answer any questions you might have.